Assalamualaikum warahmatullahi wabarakatuh. In this video, we will continue with the synchronous motor. So today in this video, we will look at the effect of field current changes on the synchronous motor. As in the previous video, we have seen the effect of load changes on the synchronous motor. So here we have the constant load. We are not changing the load, and real power supplied by the motor remains constant because we are not changing any power because not the load. So what happens if we just change the field current of this motor? So to start with, let's assume that initially the motor has the lagging power factor IA and it's operating at this IA current with the lagging power factor. Now we will increase, so this is the point, we will take, say it's the starting point, IA1. Obviously V phase is constant because we are not changing any terminal voltage. So what we will see that if we increase the IF gradually, so what can be the possibilities? Obviously if we change the IF, the induced voltage EA will change. But as the load is not changing, the power will be constant. Similarly here the power will be constant. So the currents will slide along this line and the EA will slide along this line. So if we increase the IF, suppose that the current at that point, armature current will be IA2 because current is increased, so that will compensate here IA2. As you can see that the magnitude of IA is somehow reduced, but the magnitude of EA2 will be increased. Similarly, if you increase the IF further, so what will happen? We can see that again the magnitude of IA is increased, but also with the increased magnitude of EA. Similarly, if we increase further IF, the IA will further increase in its magnitude and we will have EA4 that is also increased. But one important phenomena that we can see here is as we are increasing IF, the motor was operating initially at the lagging power factor, it can go to the unity power factor and it can go even to the increasing leading power factor. So that's how it can be used for the power factor correction also. That we will see in maybe next video. So synchronous motor initially operating at lagging power factor, and increase in the field current increases the magnitude of EA but does not affect the real power supplied by the motor. So the power supplied by the motor changes only when the shaft load torque changes, as we know. So VT or terminal voltage is also constant. Since it is kept constant by the power source supplying the motor, the distance is proportional to the power on the phasor diagram. EA sin delta and I cos theta must therefore be constant. So when the field current is increased, obviously EA must increase because EA depends on IF. But it can also do so by sliding out along the line of constant power. So as the value of EA increases, the magnitude of armature current IA first increases and then increases again. So at low EA, the armature current is lagging and the motor is in inductive load, It is acting like an inductor-resistor combination consuming reactive power Q. As the field current is increased, the armature current eventually lines up with V phase and the motor looks purely resistive. Here we can see in this figure here at IA2. Now load, this synchronous motor is acting as a resistive load here because it's now unity power factor. But as the field current is increased further, the armature current becomes leading and the motor becomes a capacitive load. So this is the beauty of this synchronous motor. It was initially at the inductor-resistor combination, then it becomes the resistive load, now it has become the capacitive load. So it is now acting like a capacitor-resistor combination, consuming negative reactive power or alternatively supplying reactive power Q to the system. So the plot of IA versus IF called the synchronous motor V curve. There are several V curves drawn corresponding to different real power levels. For each curve, the minimum armature current occurs at unity power factor and with only real power is being supplied to the motor. Here we can see that this is this curve. So we have the unity power factor which is appearing here at bottom of all these curves. So on this side we have the lagging power factors, and this is the leading power factor. So this will show us that how IF and IA will change. So if we have this lagging power factor and if we are increasing this IF, we can see here that IA is decreasing until we reach the power factor. So at unity power factor we will have the minimum IA, and then it will start increasing as IF is increased towards the leading power factor. So for field current less than the value giving minimum IA, the armature current is lagging, consuming Q. So for field currents greater than the value giving the minimum IA, the armature current is leading, supplying Q to the power system as a capacitor would. Therefore, by controlling the field current of a synchronous motor, the reactor power supply to or consumed by the power system can be controlled. Here you can see in this graph. So I hope you have understood the effect of field current changes on the synchronous motor. We will continue with the synchronous motor in the next videos. If you still have any questions, please feel free to ask. Assalamu alaikum wa rahmatullahi wa barakatuh.